The previous part of this lesson, we focused on domain and range, writing our set notation for our domain and range. We talked about continuous and discrete variables, and those are kind of things that are always going on in the background. The main thing, though, is we need to be able to graph functions, okay, and graph relationships. So when we graph them, we are able to show geometrically some sort of connection, relationship, and usually they give us some pattern. And relationships can be shown on a graph. It can be shown expressed in an equation. Relationships can be shown in tables. It can be shown in those arrow diagrams that we did earlier. So here we have our relationship. We have distance and hours. Okay, so our domain or input, our independent variable, is hours. And our dependent or output, or our y, which is our range, is the distance traveled. So the distance traveled is dependent on the number of hours we travel at 30 kilometers an hour. So this is our relationship now in an equation form. We can write this in function notation by saying that the function is dependent on the variable x, and if I input hours and multiply by 30, I'm going to get the output f of x. Okay, so we can make our table. We can show our relationship in equation form, function notation form, in a table. Okay, we can express it in words as well, which we've done up here. So the total distance based on 4 hours is going to be 120 kilometers. 12 hours, so 12 times 30 gives us 360 kilometers. 18 times 30, okay, that's going to give us 540 kilometers. 25 times 30 is 750 kilometers. And 30 times 30 gives us 900 kilometers. So if we drive for 30 kilometers an hour for 30 hours, we've traveled 900 kilometers. So there's our relationship in a table, and we can look for a pattern in the graph. So 4 hours we're at 120. 12 hours we're at 360, so it looks like 360 is about there. 18 hours we're at 540, maybe about there. 25 hours we're at 750, so 750 is right about there. And 30 is 900, which is right about there. Okay? So we can go back to our discrete and continuous. Although I've drawn this as discrete, I found discrete points on this graph. Is this problem a continuous problem or a discrete problem? Do the hours only jump from 4 hours to 12 hours and there's no time in between and distances in between? Well, that's not true. So this is not a discrete problem, it is a continuous problem, and so we want that line, that drawn, that goes through there. And in general then, this is a, oops, I think I may messed up on that one point here. Okay, so 900 is right there. And if I draw my line through there, it looks like I have a straight line relationship through there. So the pattern is a straight line relationship. And I can kind of predict using that pattern points in between. Okay, so at 10 hours, I'm at 300 kilometers. I can predict for 40 hours if I could extrapolate or go beyond this graph to where 40 would be. Okay. So this is where the graphs are useful. We can find unknown points by extrapolating, and we can also describe this pattern as a linear pattern. So it allows us to see the type of relationship that we're dealing with. And these linear patterns typically are to do with these rates. Okay, so these rates, and we'll look at these a little bit later on, but these rates, kilometers per hour, often show up as slope in an equation. So here I have 12 to 18 is plus 6 hours. Here we have that's increased by 180 kilometers. Okay, so that's what I'm seeing here. Plus 180. Here's plus 6 hours. And notice that the ratio of 180 kilometers to 6 hours, the ratio is 30 kilometers per hour. And when we have these rates, they typically show up as straight line relationships. And these straight lines have this characteristic of a constant slope. So when we talk about the dependent and independent, okay, we've already listed the dependent and independent variables. Okay, so our hours is our independent. So hours is independent. Okay, and it's usually on the x-axis, and then our kilometers or distance is the dependent, which is usually on the y-axis. Okay, the domain in this problem, it looks like our domain probably is going to be, we'll say that is our x, and realistically we're going to start with x's time from 0, and how long are we going to go? Well, I suppose this could go infinitely, so we could just say x is 0 and x is an element of real numbers because it's continuous. If we had a context to this problem, we say, well, they traveled for 50 hours, and then we would have to say, if that was true, then we would say, well, we cut it off at 50 hours. Okay? But in this case here, we have no indication that this ends, so we're just going to say that x is continuous to infinity. Okay? So given more context to the problem, we may change that. But in this case, since it's not given, we'll just say it's going to go to infinity.